You know that feeling. You're staring at this mountain of information on some new complex topic, right?
Mm.
And you just wish someone could hand you the shortcut, the aha moments, but without drowning in all the details.
Yeah, information overload is real.
Well, that's exactly what we're aiming for today. We're doing a deep dive into building generative AI solutions using Microsoft Azure. We'll be looking at two main paths: the big, comprehensive Azure AI Foundry, and then the more direct route with the Azure OpenAI Service.
Right. Two distinct approaches, really.
And our mission for you today is to unpack how these tools let developers build some truly incredible AI apps, smart chatbots, image generators, that kind of thing. But crucially, doing it all safely and making sure it can scale.
Yeah.
Now, we've gathered insights from a pretty detailed guide on building these solutions, focusing on practical steps and real-world examples.
And what's fascinating here, I think, is how Azure pulls all these different pieces together. It's this whole cohesive ecosystem. So we won't just cover what these solutions are. We'll dig into why they actually matter for anyone looking to use AI. We'll give you clear examples, connect the dots, and really frame it around responsible, effective AI deployment.
Okay, great. Let's dive in then. First up, Azure AI Foundry. Now, imagine you're maybe the tech lead at, let's call it SynthMart, a fast-growing e-commerce company. They want to use AI to totally revamp customer service. For a big project like that, you probably look at AI Foundry first, right? It sounds like this unified, almost like a developer's dream platform. What's the core idea?
Yeah, for a scenario like SynthMart, Azure AI Foundry, which used to be Azure AI Studio, by the way, it's really built to help developers build, test, and deploy generative AI apps. And the key piece here, as you said, is doing it safely and responsibly. That's baked in. It basically supports two main kinds of projects. You've got Foundry projects, think smaller scale, maybe focus on agents or specific model work, and then hub-based projects. These are really for those bigger enterprise situations like SynthMart, where you need advanced features, shared governance across teams, that kind of thing.
Okay, so you're not just like throwing AI code over the wall, you're planning it out properly, especially for enterprise needs. What does that planning actually look like for SynthMart's chatbot, for instance?
Exactly. Planning is step one. You define the use case very clearly. What exactly will this AI do for SynthMart's customers? Answer product questions, handle returns. Then you figure out the data needed. Product catalogs, FAQs, maybe past chat logs. You choose the foundation model, GPT-4o, maybe, for good conversation, or perhaps something else depending on the specifics. And crucially, right from the start, you implement responsible AI measures, safety guardrails, content filtering. You build that in from day one.
Got it.
And finally, you plan for scale. How will it run in production? How will you monitor it? So for that chatbot, scope is customer inquiries, data is catalogs, FAQs, model is GPT-4o. Safety comes from Azure AI Content Safety API to block harmful stuff. That planning ensures it's not just working, but it's safe, relevant, and, trustworthy.
Makes sense. Once you've got that plan, how do you actually get started? Setting up the structure in Azure AI Foundry sounds like there's a hierarchy.
Yeah, there's a clear structure. At the top, you have your main Azure AI Foundry resource. Under that, you create a hub. Think of the hub as a container that groups related projects. It shares settings, governance policies.
Huh?
And then inside the hub, you have your individual projects. Each project is like a dedicated workspace for a specific use case. Maybe one project for the chatbot, another for something else. You can set up the hub using the Azure CLI, the command line if you like scripting,
Right.
or create projects right from the Azure AI Foundry portal. And then you configure the key connections. Azure OpenAI for the models, Azure AI Search if you're doing RE Retrieval-Augmented Generation. We'll get to that.
Yeah, definitely want to talk about RAG.
Azure Storage for your data, obviously, and
Right.
Azure Key Vault to keep your secrets, like API keys, secure.
So that hub concept, it's really about centralizing things for bigger organizations, maybe multiple teams working on different AI bits, like at SynthMart.
Precisely. It's built for that. Shared governance, central model management. It helps keep things consistent and controlled when you have multiple teams building AI. Avoids chaos, basically.
Okay, structure set up, connections are made.
Yeah.
How do you actually get those AI models deployed and running?
Right. Deployment. Azure AI Foundry gives you options. There's standard deployment, serverless APIs, which are great for, variable loads, and managed compute deployments for more control. And you get access to a lot of models. The Azure OpenAI models like GPT-4, the new GPT-4o 3.5 Turbo, plus popular open source ones, Llama, Mistral, Phi, are all there in the catalog.
And choosing the right model, it's definitely not one size fits all, is it? I mean, the options are huge.
Absolutely not. It's a balancing act. You've got to think about the specific task. Is it text, code, images, audio, multimodal? What are the performance needs? Latency, throughput, how fast does it need to be? How many requests per second?
And cost, presumably.
Oh, definitely cost. Token pricing, the cost of the deployment itself, it adds up. And compliance data residency, security requirements. Those are non-negotiable for many businesses. So let's say SynthMart was building an internal tool, maybe analyzing legal documents. They'd need super high accuracy, strict data privacy.
Okay.
So they might choose GPT-4 for the reasoning power, use a managed compute deployment for data isolation, lock it down with private network endpoints, and add strong content filtering.
But for something simpler, maybe just summarizing internal reports.
Right. Maybe GPT-4 is overkill there. Perhaps a fine-tuned GPT 3.5 Turbo gives you, say, 90% of the value, but costs way less. Understanding that efficiency curve, finding the most cost-effective model for your specific problem, that's a really key skill.
Yeah, I can see that. Now, building these AI interactions, especially if they have multiple steps, that sounds like it could get complicated fast. Is that where prompt flow comes in?
Exactly. Prompt Flow is designed to tackle that complexity. It's a visual development tool. Think of it like drawing a flow chart for your AI application. You visually map out the steps. Okay.
You have nodes for inputs, nodes for calling the LLM, nodes for running custom Python code, nodes for defining specific prompts. It lets you build, test, and deploy these complex LLM-based workflows in a much more structured way. It also has version control, evaluation tools built in.
So for SynthMart, maybe they're building a process for handling product returns. How would Prompt Flow help structure that?
Okay, good example. You could visually design that flow. Start with an input node for the customer's request, then maybe an LM node to figure out the reason for the return, then maybe a Python node to call an API and check if the item is even eligible for return based on purchase date or something.
Right.
Then another LLM node or a prompt node to generate the specific return instructions or maybe a shipping label link. You see these common patterns like analyze the query, retrieve needed info, generate the response, maybe do a quick quality check. Prompt Flow makes building that sequence much easier. Okay, that visual approach sounds really helpful. Now, one of the big worries with AI, especially for customer-facing stuff like SynthMart's chatbot, is making sure it doesn't just invent answers. Hallucinations. That brings us to RAG, right? Retrieval-Augmented Generation.
RAG is absolutely fundamental for that. It grounds the AI's responses in your specific factual data, stops it from going off script. The basic idea is simple. Find relevant information from your documents, give it to the AI along with the user's question, and tell the AI to base its answer on that information.
Simple idea, but tricky to get right.
It can be. The quality of the retrieved information is everything. If your knowledge base is messy or outdated, RAG can actually make things worse. Garbage in, garbage out. So the human element curating that data, keeping it updated, is surprisingly critical. But the architecture involves a few steps. Ingesting your data processing documents, breaking them into chunks, vectorizing it, turning text into numerical embeddings the AI can understand, creating an index to store and search those vectors efficiently, retrieving the relevant chunks when a user asks a question. And finally, generation the LLM uses the retrieved context to form its answer.
So it's like giving the SynthMart chatbot its own private curated library, product manuals, warranty PDFs, policy docs, instead of letting it rely just on its general web knowledge.
Exactly that. And the services you typically use on Azure for this are Azure AI Search that handles the vector and keyword searching, embedding models like text embedding ADA002 to create the vectors, Azure Blob Storage to hold the documents, and a capable LLM like GPT-4 for the final response generation.
And you can make RG even smarter, right?
Yeah. Oh, yeah. You can use advanced techniques. Hybrid search combines keyword and vector search, often gets better results. Re-ranking uses another model to improve the order of retrieved documents. Conversation memory is important for chatbots, so it remembers what you talked about earlier. And source attribution, showing where the AI got its information from, builds trust. These really boost accuracy.
Okay, so you've built your flows, you've implemented RG. How do you actually know if it's all working well, if it's safe?
Yeah.
Evaluation seems critical.
Non-negotiable. You absolutely have to evaluate. Azure AI Foundry has strong tools for this. You look at quality metrics, things like groundedness, does the answer actually stick to the source material you provided? Relevance, does it answer the question? Coherence, fluency.
The usual suspects for language quality.
Right. But just as important, maybe even more so, are the safety metrics. Detecting hate speech, unfairness, violence, sexual content, self-harm related content. Proactively scanning for that. For a company like SynthMart interacting with customers, this isn't just a technical check. It's fundamental to trust and brand safety.
So what are the best practices for doing evaluation well?
Use diverse test datasets that cover lots of scenarios. Compare the AI's performance against human benchmarks. Is it as good as a person would be? Monitor continuously once it's live in production. Things drift. A/B test different models or prompts. And create domain-specific metrics. For SynthMart, maybe measuring the accuracy of product recommendations or if it correctly applies the return policy. You can even build custom evaluation flows in AI Foundry to check very specific business rules or compliance needs.
This all sounds incredibly powerful, but also complex to manage. How does a developer actually integrate all this into a real application that SynthMart's customers or employees use?
That's where the Azure AI SDK comes in. It gives you programmatic access, code-level access to everything. Managing projects, deploying models, running those prompt flows, triggering evaluations. For authentication, controlling who can access what you've got options. Simple API keys for basic use. Microsoft Entra ID that used to be Azure AD for proper enterprise identity management. Or managed identity, which is great for Azure services, talking securely to each other without needing to handle credentials manually. In production, people often use a microservices architecture. Maybe one service handles the chat interface, another handles the RA calls, another handles the LLM generation. It helps with scale and resilience.
And resilience is key, I imagine. Things can go wrong.
Absolutely. Robust error handling is critical. Implementing retry logic, using exponential backoff if an API call fails or gets rate limited, that prevents the whole thing from falling over if there's a temporary glitch. You need that for a good user experience.
Right. Okay, that gives us a really good picture of the Azure AI Foundry path, the big integrated platform. Let's pivot now. What about the Azure OpenAI Service? If Foundry is the whole suite, where does Azure OpenAI Service fit in? Is it totally different?
It's a different approach, yeah. It's more focused. It's ideal for developers who need direct API access to OpenAI's cutting-edge models, but maybe don't need the entire AI Studio Foundry framework around it. Think of it as getting those powerful models, GPT-4, DALL-E, etc., directly, but hosted within Azure, benefiting from Azure's security, reliability, and compliance features. Enterprise-grade OpenAI, essentially.
So if SynthMart wanted to, say, quickly build a small internal tool, maybe something for marketing to generate ad copy variations using GPT-4 without a full Foundry project setup, this might be the way.
Exactly. Or if they already have an application and just want to add a specific AI capability via an API call.
How do you get that set up? Is it simpler?
Generally, yes. The initial setup is more direct. You provision an Azure OpenAI Service resource, again using the Azure portal or CLI. The key things you configure are networking. Do you want it publicly accessible or locked down using private endpoints for maximum security within your network? Or maybe accessible only from specific networks.
Private endpoints sound important for sensitive data.
Very. It means the traffic between your app and the AI model never goes over the public internet. And then authentication again, API keys, Microsoft Entra ID, or managed identity are your options. So that SynthMart marketing team could spin up an OpenAI resource, maybe keep it internal only with private access, use Entra ID for authentication, and start calling the GPT models right away.
And the models available through this service, it's quite a list, isn't it? Not just one type of GPT.
Well, the portfolio is huge and constantly growing. You've got top-tier reasoning models, sometimes referred to by internal codes, like O3 for really complex stuff. O3 Mini may be better for coding tasks. Then the foundation models we know. GPT 4.1, which has that enormous 1 million token context window.
1 million tokens. That's massive. You could feed a huge document.
It's huge. Entire books, long transcripts, game-changing for certain tasks. Then GPT 4.0, the really powerful multimodal one, handles text, images, audio altogether. GPT 4 Turbo, GPT 3.5 Turbo for speed and cost-effectiveness. Plus specialized models, embedding models, image generation models like DALL-E 3, and this newer GPT Image 1, which is in preview.
Okay. And models for speech-to-text, whisper, and text-to-speech, TTS. It's a whole suite of capabilities.
And just like with Foundry, there are different ways to deploy these, affecting performance and cost.
Yes, two main ways here. Standard deployment is pay-as-you-go per token. It scales automatically, which is flexible. But if SynthMart knows they'll have consistently high usage for their main chatbot, for example, they might opt for provision throughput units, or PTUs. That means you reserve a certain amount of processing capacity. It gives you predictable performance and often better latency under heavy load, but you pay for that reserve capacity whether you use it fully or not.
So it's a trade-off, predictability versus flexibility.
Exactly. And choosing the model itself still follows those same guidelines. GPT 4.1 for deep reasoning, GPT 4.0 if you need multimodal, 3.5 Turbo if speed and cost are paramount for simpler tasks, specific GPT-4 versions for coding. Match the model to the job.
Okay, model deployed via Azure OpenAI Service. How do you actually interact with it? Send it prompts for text or code. It's all through API calls. You send your prompt, usually structured with the system message to give context, you are a helpful assistant, and then the user's query. You specify parameters in the API call, like max tokens to control response length and temperature to control creativity. Lower temperature means more focused. Deterministic output good for code, higher means more creative.
Right.
For code generation, you'd give very specific instructions in the prompt. And you can stream the responses back, so for a chatbot, the text appears word by word, which feels more interactive.
It raises the question again, how do you write a good prompt? Seems like an art form.
It's definitely a skill. Prompt engineering. Best practices usually suggest a clear structure. Define the task, provide context, list specific requirements for the output, maybe include examples of what you want. Clear, structured prompts get better results. And again, error handling is crucial. Your code needs to handle things like rate limit error if you send too many requests, or API connection error if there's a network issue. Use retries, use backoff. Be resilient.
Makes sense. Now, you mentioned image generation models like DALL-E 3. So SynthMart could use this service to create marketing images too.
Absolutely. Through the Azure OpenAI Service API, you can call DALL-E 3 to generate images from text prompts. And there's also GPT Image 1, which is in limited preview but promises even better results, following instructions more closely, rendering text within images more accurately, even doing some basic image editing based on prompts.
So you could literally just ask it for, I don't know, a hero banner for SynthMart's summer sale featuring beach gear in a bright, optimistic style.
Pretty much, yeah. You'd specify the prompt, the desired size, maybe quality, or ask for an infographic detailing return steps using SynthMart's brand colors. And importantly, these image models also have content moderation built in to prevent the generation of harmful or inappropriate images. That's critical for brand safety.
The potential for marketing and creative teams seems huge, just generating assets on demand.
It's a massive productivity boost. Custom icons, social media graphics, website banners, all from text.
And then we get to the really futuristic stuff. Multimodal models like GPT 4.0 or GPT 4 Turbo with vision. They can see.
In a sense, yes. They can process and understand images you provide and then respond textually about them. It blends language understanding with visual understanding.
So I can literally show it a picture of a SynthMart product and ask, what's the warranty period for this? Assuming the info is somewhere visually represented or associated, or maybe analyze a sales chart.
Exactly. You can provide an image URL or even upload a local image encoded in base64 format, and then you can ask it to do things like perform OCR to extract text from the image, describe everything it sees, count objects, judge the quality of a product photo, or, yes, analyze a chart and explain the trends or extract key data points.
Wow. How did that translate to real-world business use for SynthMart?
Think about automating document processing. Feed it images of invoices or contracts and ask it to extract the key information into a structured JSON format. Huge time saver. Or quality control in manufacturing, analyze images of products coming off the line to spot defects or assembly issues. You can even run these analyses in batches on many images at once. It opens up a lot of possibilities for automating visual tasks.
Okay, that's seriously impressive. Finally, within Azure OpenAI Service, there's something called the Assistance API. This sounds like it takes things even further, building more capable AI agents.
It does. The Assistance API lets you build more stateful, tool-using AI assistants. They have custom instructions you define, they maintain a persistent conversation history or thread, so they remember context over longer interactions. And crucially, they can use multiple tools to perform actions or access information.
Tools? What kind of tools can these assistants use?
There are 3 really powerful built-in tool types right now. First, Code Interpreter. This lets the assistant write and run Python code in a sandboxed environment. It can analyze data files you upload, like CSVs, Excel sheets, create charts and visualizations, do statistical analysis. It's like giving your AI its own little data science workspace. SynthMart could have an internal assistant analyze weekly sales data automatically.
Okay, that's one. What else?
Second, function calling. This is huge. It allows the assistant to call external APIs and tools that you define. So your SynthMart customer support assistant could have functions like get customer order status that calls your internal order database, or create support ticket that integrates with your help desk system.
So the AI can actually do things in other systems.
Exactly. It lets the AI take actions, interact with your real-world systems based on the conversation.
Amazing. And the third tool?
Third is file search. This lets the assistant search across a knowledge base of documents that you provide. Think company policy documents, product manuals, HR handbooks. The assistant can retrieve information from these specific documents to answer questions accurately and even provide citations. An HR bot at SynthMart could instantly find the relevant section of the vacation policy.
Code interpreter, function calling, file search. That combination sounds incredibly powerful for building sophisticated agents. So how does SynthMart, or any company, actually integrate these assistance API capabilities into their apps?
You typically interact with the Assistance API from your application code, maybe build it into a web app using something like Flask or Django if you're using Python, or integrate it into a larger microservices architecture where maybe one service manages the assistant interactions. Security remains paramount, of course. You'd use API keys or preferably Microsoft Entra ID or Managed Identity for secure authentication between your app and the Azure OpenAI service. It's about embedding this intelligence securely and reliably.
Okay, this has been a fantastic exploration. We've covered a lot of ground looking at these two major paths on Azure. So when you boil it all down, what does this mean for you, the listener, trying to navigate this generative AI landscape on Azure? We saw the comprehensive AI Foundry and the direct Azure OpenAI service.
Yeah, and stepping back, looking at the bigger picture from both approaches, you start to see these recurring themes, these critical success factors that really matter, regardless of the specific tool. First, model selection. Really understanding the trade-offs and picking the right model, GPT-4o for multimodal, DALL-E for images, maybe 3.5 turbo for speed for the specific job. Don't just default to the biggest model.
Right, cost and efficiency matter.
Second, responsible AI and evaluation. It's not an afterthought. Building in safety from the start and constantly evaluating for both quality and safety. That builds trust. Third, prompt engineering. It's a genuine skill. Crafting clear, effective prompts is key to getting good results consistently. Fourth, data grounding with RAG. For most business use cases, you need the AI to work with your data accurately. RAG is essential for that relevance and trustworthiness.
Avoiding those hallucinations.
Exactly. Fifth, security and scalability. Protecting your data, using things like private endpoints, and making sure your solution can handle real-world load. And finally, integration. Thinking about how to weave these AI capabilities smoothly into your existing applications and workflows to actually deliver value.
This deep dive hopefully gives you the knowledge not just to understand the buzzwords, but to see how these tools can solve real problems, building new things, optimizing old ones, and maybe help you avoid some common bumps in the road. We really hope this is giving you that clearer shortcut, that path through the complexity of generative AI on Azure. There's obviously a lot here, but the potential is just incredible.
It really is, and maybe this leaves you with a question to think about. How could using one of these advanced AI assistants, one that can interpret code and search your internal documents and call external tools, how could that fundamentally change how your team or your whole organization works with information, makes decisions, and maybe even drives innovation, something to mull over?